coming to our talk, Team JaM and Systems Wonderland.
We're going to talk about how we got into systems programming through Rails Girls Summer of Code. And our team name during the summer was Team JaM, and I'm the J in JaM, Jeena.
I'm the M in JaM, Malisa.
So we are students in bioinformatics, which is the child of programming, biology, and statistics. And we knew some Python when this strange bunny appeared in front of us this spring.
Hi, my name is Rails Girls Summer of Code. Come join us for a summer of code and fun.
And so during the application process, we had to choose a project, and one caught our attention.
And that was Servo, which is a web browser engine.
And we later learned that web browser engine is the heart of a web browser, and we didn't know what that actually meant, but it sounded cool. Plus, the logo is very Doge, much cuteness, so.
So we chose Servo, and we followed the bunny down the rabbit hole.
And we landed on Systems Wonderland. And so we were so confused. We thought we were going to work on a web browser engine. Like, why are we here? What is systems programming?
So in order to learn what a system is, it helped us to think about it in the context of something like a donut tower. So if you want to build a donut tower, you got to build the bottom layer first. That is the system, and on top of that, you can build the other donut layers. So we learned that systems programming is about building a foundation on top of which you can build other software. And in that sense, a web browser engine is a system on top of which you can build web apps.
So Servo, the open source project we worked on over the summer, is a web browser engine, which is the heart of a web browser. And it's written in Rust, which is a new language. And it aims to be safe, fast, secure, all the good things you want from a web browser. And it's getting written completely from scratch, so that's very exciting. It's kind of like the new kid in the block.
And so for our project, our mentor JaM told us to make fetch happen.
And we were like, what is fetch?
So this is how we understand it. Say you are JavaScript who lives in the web browser engine in the web world.
And sometimes you get data that's kind of far away from you, and you can go get it yourself, but there's a small problem. When you leave your home, the web browser engine, who's going to take care of the house? You don't want to leave the house unattended because it means that nobody will be able to scroll or click things or drag while you're gone.
Luckily, you have a loyal servant who'll get the data for you.
So you send off the loyal servant to get the data for you.
What are you going to do while your loyal servant is getting the data? One thing you can do is just stop everything and wait there. Or
you can go back to your home and make yourself a cup of coffee,
make some eggs,
eat a donut,
write a to-do list.
And in the web world, it would mean that your home web browser engine keeps working. You can still scroll, drag, or click things instead of everything just pausing.
And when the data is available for you again, the loyal servant will let you know.
And then you can pick up where you left off and consume the data.
So one of the good things about the loyal servant is that it's clever and can process the data according to its format, whether it is text, blob, or form data, and then it's easier for you to consume it.
So going back to where we started, in summary, in the web world, say you're JavaScript, you live in web browser engine. Sometimes you get data that you want to retrieve that's kind of far away, and you can get your loyal servant to get it for you. And it turns out this loyal servant comes in two kinds.
The first kind is called XML HTTP. And while it's functional, it is not pleasant to work with.
And the other one is fetch, which is so much easier and cleaner to interact with. And so it's just pleasant all around.
So in conclusion, our goal for the summer was to implement the JS Fetch API for Servo.
So far we learned that web browser engine is the heart of a web browser. Fetch is one way to get data. So we're like, okay, now we know what we need to do. What is our tools?
We opened our toolbox, and there was Rust.
And so Rust is a new systems programming language such as C or C++, and it aims to be fast and memory safe, which is unheard of. And the syntax is so much nicer compared to C or C++. It reads like a much higher level language. So we knew that we had to learn Rust because Servo is written in Rust, and we had a lot of fun learning this language. But we also learned two unexpected things over the summer.
So one of the concepts that we had to wrap our minds around is that even though Fetch is a JavaScript API, it is implemented in Rust or C++ and other web browsers. And so as you might imagine, this requires a whole lot of glue code, which allows the two languages to work smoothly together. Luckily for us, we mostly just had to worry about the Rust side of things, but we've realized that there's been a whole lot of code that went into making this possible.
And the other thing is that web browsers should be predictable. When you call new headers, you should get new headers no matter which browser you're using, including Servo. And it turns out there are standards that ensure consistency in the web world. So when we're implementing the fetch API for Servo, we follow the fetch standard defined by WhatWig so that our fetch behave the same way as other browsers fetch. And before the summer, we never knew about the standards. So it was very interesting to learn about these organizations, the people, and the effort that goes into making sure that the web behaves consistently and predictably. And it's kind of sad because it's almost as if like they're invincible. Like they care about this so that the web developers don't have to worry about like weird behaviors. Like you don't want to get new body when you call new headers, for example. So we learned that all of these things happen behind the scene.
So as our summer went on, we noticed that our mentor, JaM, kept using the phrase just work with capital letters. And we learned that this phrase is a reference to how we take a lot of things for granted, even though they just seem to work. But behind the scenes, there's actually been a whole lot of work done so that things can just work.
So for example, when you click a cat GIF link, you expect it to just work and you'll see a cat eating a donut or whatever. But when you think about it, there were people who wrote the standards, people who debated whether a certain approach was the best approach. There were people writing the glue code so that the JavaScript API could talk to the lower level language. There were people implementing the details, and the list just goes on and on.
On that note, fetch works. After our summer, we were able to implement the bulk of the fetch API, and these are just some snippets from the weekly server blog.
Yeah, and our fetch just works, meaning in order to implement the fetch API, we had to implement other APIs such as headers and requests. We won't go into details today because of the time constraint, but if you're curious how we did it, please come talk to us. We would love to talk.
So we worked hard to get to that point, but we also got a lot of help.
And honestly, it felt like jumping off a cliff sometimes. We had no idea what we're doing or like, where are we going.
But we learned that whenever we admitted we didn't know anything, people were there to help us out.
So this is cliche, but true, so we're going to repeat it anyways.
We learned that the unknown does not have to be scary.
And we've heard of this phrase many times, but it truly made sense when we actually did something completely new to us. So maybe you won't realize it until you try something out of your comfort zone.
With that in mind, in the wise words of Shia LaBeouf, just do it.
Just do it. And because we just did it before the summer, we knew some Python.
But now we learned so much about what else is out there.
And so Confucius once said, I hear and I forget, I see and I remember, I do and I understand. And we think it means that if you want to understand something, doing is the fastest way to get there.
By doing, we got to understand what was inside the black box called the web, and we also got to appreciate it more.
So we got to appreciate the web once we understood the foundation a little more, and we believe you're the people who make the web interesting and exciting and useful. So if you're curious about that bottom layer of donuts and you want to see how it's built, try it out. Like, go dig in, see how the donuts are stacked or whatever. And we think you'll appreciate your work from a whole different perspective and understand them better too, because you know the bottom layer, you know how to build the top layer too. Plus, it's fun to learn new things. So just do it. So to continue this trend, you can do it yourself. Try something new. Luckily, web browser engines are open source, except for those from Microsoft. Even standards are open source, meaning you can just go and join the discussion and help people shape the future of the web, which is really exciting. One great thing about Servo is that because it's so new, there are many, many easy tasks waiting for new contributors. So if you're interested in contributing to Servo, come talk to us.
Another thing you can do is to help others try new things by becoming a mentor. Over the summer, we had a mentor, 2 coaches, and a supervisor, not to mention the GitHub and IRC communities helping us out. So that's like a greater than 2-to-1 ratio of help. And without them, we couldn't have done this. We also want to mention that you don't need to be an expert on the specific project that you're mentoring. For instance, our coach Stefan taught us a lot of general knowledge about GitHub and like how fetch differs from XML HTTP requests.
So thank you again for joining this evening, and follow our journey of learning on Twitter.
We'd like to thank our Rails Girl Summer of Code crew, the Servo and Rust communities, and Donut.js for having us.